Have you ever wondered how a company tests a brand new product before it's even built? Well, today, that's exactly what we're going to do. We're going to deconstruct a fascinating and really critical job, and we're going to do it by digging into a real-world job description. I mean, seriously, think about it. You're designing a new phone, a critical car part, maybe even a life-saving medical device. How on earth do you know if it's going to break, or overheat, or just completely fail under pressure before you spend a fortune building a real one? That's the puzzle we're solving today. Now, the answer isn't magic, but it's pretty close. It's this incredible mix of engineering, data, and pure problem solving. It takes a special kind of expert who acts like a digital detective, investigating products in a virtual world to prevent real-world disasters. All right, so let's pull back the curtain. In this first part, we're going to reveal the official name of this digital problem solver and really get to the heart of what they do every single day. And there it is, the application engineer. This quote is pulled directly from a real job posting, and the key phrases here are support customer simulation projects and analyze products. What that really means is they're not the ones designing the product from scratch. Instead, they take a customer's design and basically test it to its absolute limits, all inside a computer. But here's the thing, this job is so much more than just clicking buttons on some fancy software. The application engineer is actually a crucial bridge, a link between two very different worlds. And you've got to understand that to really get what their mission is all about. Now, this slide right here really clears things up. See, a design engineer is usually internal, creating something brand new from a blank slate. But the application engineer, they're customer-facing. They are the expert who takes this incredibly powerful software and applies it to a client's very specific, very real problem. They're focused on analysis and simulation. In a way, they're like a translator between the software's amazing potential and the customer's actual needs. So, what kind of digital tools does our engineering detective actually use? Let's take a look inside their toolkit. And don't worry, we're going to make sense of all the technical jargon. The job description firmly plants this role in the world of CAD, CAM, and CAE. That stands for Computer-Aided Design, Manufacturing, and Engineering. Think of it as a digital journey. First, you design the thing, that's CAD. Then you analyze it to see if it works, that's CAE. And finally, you figure out how to build it, CAM. Our application engineer, they live right in that sweet spot, the analysis phase. And the core technique they use, this is the secret sauce, is called finite element analysis, or FEA. The best way to think about it is like this. To understand how a really complex car door will react in a crash, the software digitally shatters it into millions of tiny, simple blocks, like digital Legos. By calculating the forces on every single one of those little blocks, it can predict with incredible accuracy how the whole door will bend, break, or, well, hopefully it hold up. And this shows you exactly what they're testing for. A static analysis makes sure a bridge can hold its own weight. Dynamic analysis is what simulates a car crash, which leads to safer cars for all of us. Thermal analysis is why your laptop doesn't just melt on your desk. NVH, that stands for noise, vibration, and harshness. That's all about making cars feel quiet and smooth inside. And fatigue analysis, that can predict exactly how many times you can use a medical implant before it fails. It's incredibly important stuff. Now, the job spec is super specific about the main tool, ANSYS. It's an absolute powerhouse, a whole suite of simulation tools. The posting even calls out specific experience with its modules, like LS-DYNA and Mechanical. This is the digital laboratory where all that incredible testing happens. Okay, so they've got the tools, they've got the techniques, but what's the point? Let's talk about the real-world impact. How does all this digital analysis actually lead to better, safer, and more reliable products that we all use every day? So here's how it usually goes. It's not just about crunching numbers in a dark room. It all starts with a conversation, really getting deep into the client's problem. Then, sure, comes the intense technical work of the FEA analysis. But the final steps are maybe the most critical of all. It's about communication. You have to present those complex results in a way people can actually understand, and then provide those golden insights that will directly improve the product's final design. And that's the key takeaway here. This is not just a numbers job. The job spec specifically calls out training customers, creating reports, and collaborating with design teams. It's a role that demands amazing communication skills. You have to be part analyst, part teacher, and part consultant, all rolled into one. So now that we've really broken down this role, let's look at the blueprint for the person who fits it perfectly. Could this be a career path for you? Let's find out. Okay, first thing to notice, the experience level required. Just 1 to 3 years. That is a massive green light for recent grads or anyone who's still pretty early in their engineering career. It's a high impact, really powerful role that you can get into without needing decades of experience. And here it is, the complete skill breakdown. On the hard skills side, yeah, you absolutely need hands-on ANSYS experience and a rock-solid understanding of FEA theory. But just look at the soft skills column. Strong communication, problem solving, and managing multiple projects. They're given just as much weight, which proves this role is a perfect blend of technical mastery and people skills.
So, to wrap it all up, the application engineer is really a linchpin in how things get made today. They stand right at that intersection of powerful digital tools and real world engineering challenges, acting as an analyst, a teacher, and a vital collaborator, all at the same time.
And that leaves us with one last big thought to chew on. As building physical prototypes gets more and more expensive, and these digital tools just get more and more powerful, could this simulation-focused client-facing engineer become the new, true face of the entire profession? What do you think?